Problem 11.2, determine the area between the curve f equals x times x squared minus 1 over x squared plus 1 to the 3/2 and the x-axis. Okay, so let's see what this function is like. Okay, it's obviously an odd function, right? This part is even, this part is even, but this is odd. So you multiply an odd function by an even function, you get an even function. Sorry, an odd function. And so we know that odd functions are going to go through 0, which is obvious here, and that they're going to be mirrored with respect to the x-axis and the y-axis. Okay, so and so the two zeros apart from 0 are 1 and minus 1, right? Now between 0 and 1, this is always positive, right? So we have, this is positive, this is negative between 0 and 1. So we have a negative function, and maybe we don't need to compute the maximum value, but this is something like this, and this is going to be symmetrical with respect to the other side. Okay, so the area that we're looking for is this one. Okay, now this is obvious that the area that we're looking for is 2 times the area between 0 and 1 of the absolute value of f, right? Now this is, as we know, this is going to be a negative area, so we can compute the area of minus f, which is just changing the sign here in the product here. This is 1 minus x squared divided by x squared plus 1 to the 3 over 2, right? And again, this is one of those, remember, this is the square root of x squared plus 1 times x squared plus 1, right? This is what it means. So whenever we have something like this, we always change the variable to x equals the tangent of t. So that dx is the derivative of the tangent, which is 1 plus the tangent squared, which is 1 plus x squared, right? dt. Right, and so that allows us to get rid of this, and then we have in other words, and this is equal to the second x squared plus 1 is equal to 1 plus the tangent square, which is equal to the second square, right? So we have that here. So let me write that somewhere. Let me erase this here. So x is the tangent of t. Dx over 1 plus x squared is going to be equal to dt, and x squared plus 1 is equal to the second square root of t. Now I erase this too, and so now we have the integral between, and then let's see, when x is 0, the tangent is 0, of course. When x is 1, the tangent, t is pi over 4, right? That's the angle that has tangent 1. And so here we have x is the tangent, 1 minus x squared is 1 minus the tangent squared of, you want, let me write it like that first, and then this is divided by x squared plus 1, dt, sorry, this is dx, I don't know why I wrote the dx, dx divided by 1 plus x squared is dt, and the square root of 1 plus x squared is the second of t. Okay, now let's see, this is the same as multiplying by the cosine, so this is 2 times, and then we have 0 pi over 4, the sine divided by the cosine multiplied by the cosine, you have the sine of t, you have 1 minus the tangent squared of t. So you have 2 integrals here, 2 times this from 0 to pi over 4 of the sine of t dt, minus 2 times the integral between 0 and pi over 4 of the sine, and then let's see, this is the tangent squared. Okay, let me go down. So the first one is easy, right? This is 2 times minus the cosine between pi over 4 and 0, and so let me write this. This is 2 times the integral between 0 and pi over 4 of the sine of t dt, and the cosine of t at pi over 4 is let's see, well, the cosine, this is the same, minus the cosine of t is equal to the cosine, the cosine of pi over 4 is the square root of 2 over 2, so this is minus the square root of 2. The cosine of 0 is 1, so this is plus 2. Okay, that's the first integral. Now, what happens with the second one? We have 2, the integral between 0 and pi over 4 of the sine of t, tangent squared. Now, how do we deal with this? Well, instead of having this, we can write this as the tangent squared, remember, is 1 minus 1 over the cosine squared, or sorry, yeah. The tangent squared plus 1 is the second, so the tangent squared is the second minus 1, okay? So the second cube minus 1, okay? Now, so this is, let's see, this is minus 2, okay? So this is minus 2, the primitive of the sine of t divided by the cosine squared, okay, which is going to be easy to do now. And then we have plus 2 times the integral between 0 and pi over 4 of the sine of t. Okay, but this is just exactly what we did here. We could actually sum this here. So this is 4 equals 4, and then this is 2 plus 4. Okay, so we can erase this part, and we will so let me write this. This is 4 minus 2 the square root of 2 minus 2 the integral between 0 and pi over 4 of the sine of t cosine of t to the minus 2. Okay, that's what we have. So now we have 4 minus 2 the square root of 2 minus 2, and then what's this? The integral of this is minus 1/3 of the cosine of t to the minus 3, right? With a minus because the derivative of the sign is plus, okay? Sorry, it's minus the sign, so we have that between 0 and pi over 4. Now, let's see. We have, sorry, no. This is, sorry, the primitive, this is the sine of t times the cosine of t to minus 2. So you have minus 2 plus 1. So this is minus 1. The times the cosine of t to the minus 1. Okay. But then times minus 1 again because the derivative of the sine is minus the cosine between 0 and pi over 4. Okay. Sorry about that. Now what's the cosine of t? Sorry, it's 4 minus 2 square root of 2 minus 2, and then we have the cosine of t when this is pi over 4 is 1 over the square root of 2 divided by 1 is the square root of 2. And then we have, let's see, minus 1, okay? So this is 6 minus 4 the square root of 2, if I'm correct.